Good afternoon, Year 10. Good afternoon, Miss Sturgis. Today we are going to learn about parallel vectors. Now, this isn't a particularly complicated concept, but it's a really important one for vector proof. Also, the GCSE textbook sort of runs out of things to do at this point, so I have moved on to an A-level textbook. This is going to be useful for you for several reasons. Firstly, it covers stuff you do actually need for your GCSE, so I'm not sure why it's not in the textbook. But secondly, it gives you a more advanced idea of vectors, which should make the GCSE stuff seem a bit easier. And it means if you do go on to do maths at A level, you'll already know some of the content. So on that note, let's get started. When we talk about vectors, there are two things to consider. This vector is the vector A to B. Now, the vector A to B is using the move A. So A to B equals the vector A. Now, the vector A can be moved around in space. The vector A to B cannot. This AB with an arrow on it represents the vector joining these two fixed points, A to B. However, this represents the size of the vector and the direction of the vector. So we can say that PQ, if we look at this one, P to Q is also equal to A. So A to B is the vector A, because that's just the direction it has, and P to Q is the vector A, because that's the direction it has. So we can also say that these two vectors, A to B and P to Q, are equal. However, they do not represent the same points in space. A comparison in number would be if we do 3 plus 2 equals 5. This is a particular number, and these are two particular numbers, and 3 plus 2 makes this 5. However, we could also have 4 plus 1 makes 5. So we've got two different sets of numbers that make the same resulting number. And that's what's happening with these vectors. We've got two distinct sets of points. A and B are the points over here. P and Q are the points over here. But the actual vector connecting them is the same. So different points, same vector. Different points, same vector. So the vector, the line that's parallel to A, can just be moved around. But if we move it around, it's not connecting the same points anymore. This P is fixed in space and this Q is fixed in space, but this A is a measurement of the distance between them. It is the direction and measurement of how we get from P to Q. So these two vectors, the vector taking us from A to B and the vector taking us from P to Q, are equal to each other, but they are not necessarily in the same point in space. A to B is over here and P to Q is over here. Now, if we have the AB equals PQ, then that means AB and PQ are equal in length. And parallel. When they don't have the arrows above them, it's just representing the line segment. So AB without an arrow is just talking about this. Ooh, I should add that to a bloopers reel. So this is just representing the line segment, so it's just this length. Whereas AB with an arrow above it is describing the direction as well, so we're going from A to B. Copy this down, please, and make a note about line segments. So AB is a vector. AB with no arrow is a line segment. Now, once I have one vector, so A to B is A, I can also reverse the direction, so I could go from B to A. But because it is a direction, that will be negative vector A. So if AB equals negative BA, which it always will, if you have a letter here and a letter here and then you swap their order, this will be equal to the negative of the swapped order. So A to B is the negative of B to A, which means AB and BA, remember that's the line segments, are the same length. In opposite directions, and still parallel. So copy that down as well, please. Before we go on to another important point about parallel vectors, just want to talk about the triangle law for vector addition. So let's say we had 3 points. We've got A, B, and C. If we want to get from A to C, let's call this one C, and then let's call this A and B. When we map out vector routes, we think about how we can get from one point to another point. So we've got, if I wanted to get from A to C, I could go straight from A to C, or I could go from A to B, and then from B to C. Now, since A to B equals A, and B to C equals B, and A to C equals C, that means that C is equal to A plus B. And that is the triangle law in vector addition. Essentially, the route from one point to any other point is always equal no matter how you get there. So if I'd gone from A to another point up here, to another point here, and then down to C, that entire route would be equal to the direct route C. In vector terms. Not in length terms necessarily, but certainly in vector terms. Now let's say I've got two vectors A and B. We already know that A would be parallel to A. But what if I made it twice as long? So I've got 2A. They would clearly still be parallel. It is the same direction that they are moving in. So A and 2A would still be parallel. And so would negative a half A, because it is the A part, not the scalar part, that determines the direction. And any vector that only has A in it is going to be moving only in this direction, and so they will be parallel. The same with B. Pretend I've drawn a very good parallel line there. If we have minus 2B, or negative 2B, sorry, it'll be moving in the opposite direction, but it will still be moving along the same direction plane. So 2B would be moving in the same direction parallel, and then when we put a negative on, we're just reversing it. So actually, if we take any vector A, will be parallel to some constant, let's call it lambda times A, where lambda is a constant. So that is important to note. Any vector A will be parallel to another vector, which is A times just by a constant, because it just extends the line out. So this is A, this is 2A. All it's done is extended it out. They are still parallel. So I can't quite see where, so I'll move that up slightly. Can you please copy that down? Now we might have a combination of vectors. So here we've got that C is equal to A plus B. And here we've got that 2C is equal to 2A plus 2B. If I factorise the 2 out of there, this is just some lambda or a constant times this. If a vector, so 2C, is a multiple of another vector, so A plus B, then that means they are parallel. So this is parallel to A plus B, because it's 2 times A plus B, which means that C is parallel to 2C. Now we would expect that anyway, because this is clearly a multiple of this. 2C is clearly a multiple of C, so they are parallel. I'm just demonstrating that the way you would show two vectors are parallel is you'd find one of them in terms of all of its components, A and B in this case, and then you would show that the other one is a multiple of those same components. So we're going to do a few examples now, which will hopefully make what I've said a bit clearer. So the first one is show that these two vectors are parallel. So show that the vectors 6A plus 8B and 9A plus 12B are parallel. So if we have a look at these, what we want is, we want these two coefficients to be multiples of the same number. We want these two coefficients to be multiples of the same number. And you can hopefully see these are both multiples of 3 and these are both multiples of 4. So I'm going to write out 6A plus 8B, that is equal to 2 into 3A plus 4B. And then this one, 9A plus 12B, that is equal to 3 into 3A plus 4B. So they're both multiples of the same thing, but we have to show that they're multiples of each other. So if I divide this vector by 3, I get 3A plus 4B. And then if I times it by 2, I get 6A plus 8B. So actually, I've got that 6A plus 8B is equal to 2/3 of 9A plus 12B, and therefore they are parallel, because this entire vector is a multiple, and it can be a fraction, of this entire vector, and so they are parallel. So copy that example down, please. Okay, next example. ABCD is a parallelogram. A to B equals A to D equals B. Find AC. So I want to find this distance to this distance. Now, because this is a parallelogram, this line is moving in exactly the same direction as this line. And this line is moving in exactly the same direction as this line. Now remember that if I want to get from A to C, any route is acceptable. I don't know how to get from A to C on this direct route, but what I can do is go from A to B, which is vector A. Actually, I'm going to write the steps in. So I'm going to go from A to B, and then I can go from B to C because it's parallel to this one, so I do know the vector that represents that line. And in fact, when we are breaking a route down like this, the last letter in this vector should be the first letter in this vector, because that is the point you've ended on with this one, which means it's the point you start on with this one. A to B is going to be A, B to C is going to be B. So actually the vector A to C is just A plus B. Quite an easy example there for you. Our last example is to do with ratios in vector questions. Now, we have got, I want you to copy this down please so you've got it to refer to, because I'm going to need to move this board away and then work on another board. In triangle ABC, A to B is equal to A and A to C is equal to B. So vectors. P is the midpoint of AB and Q divides AC in the ratio 3 to 2. We've then got to find these vectors B to C, A to P, A to Q and P to Q. So copy that down, pause the video and copy it down, because I am going to start working now on a new board. So the diagram that we were working with, I'm going to draw that again here, was A, B, C. We've got a midpoint P and we've got another point Q. Now the question also said that A to B, so we're moving in that direction, that's really important, is A. And it also said A to C, again, direction, really important, is the vector B. Now it said it said point P is the midpoint, so that means that's splitting this line into two halves. However, it said that Q divides AC in the ratio 3 to 2. So this bit makes up 3 parts and this bit makes up 2 parts. So there's 5 parts in total. So it's 3/5 and 2/5. That is how the line is split. So that is the first thing I would do, is I would draw everything I know onto the diagram. So just as a double check, A to B is A to B is A to C is B, A to C is B. P is the midpoint, so splits the lines in half. Q divides in the ratio 3 to 2, so 3 out of 5 and 2 out of 5. I now need to write the following vectors: BC, AP, AQ, PQ. So the first one, B to C. I can't go directly from B to C because I don't know this vector, but I can go from B to A and then from A to C. B to A is minus A to B. A to B is the vector A, so B to A is the negative of that. Then A to C is just B, so I'll have B minus A. Next one, we are finding the vector A to P. Now A to P is half of A to B. And A to B is vector A, so it's just a half of A. Part C, we are finding the vector A to Q. A to Q is 3/5 of A to C. So it's just 3/5 of vector B. And then finally, P to Q. We can't go straight from P to Q, but we can go from P to A and then from A to Q. P to A is the negative of A to P, always, if you switch the letters or you switch the direction, it makes it negative. A to P is a half A, so it's negative a half A. A to Q is 3/5 of B. So it will be 3/5 of B minus a half A. Okay, that is a much longer video than usual. Hopefully those examples made sense. I'm going to put some questions up for you to have a go at, and that should be everything you need to be able to do these questions. But if you get stuck, please let me know.